Hello Geometry 2 9.3 Composite Figures, which is a word that we've used in the past, that composite piece. And composite means multiple things together. Like composite board is when they take all the scraps of wood and put it together to create one like composite board. So composite means combining different shapes. Like this picture, you'll see a semicircle and a triangle, and so we're going to add all of that up, or in this case, take a square and subtract something. So composite figures can be adding things together, or it could be subtracting different pieces from a whole shape. So our essential question is, can I find the area of composite figures? And I would actually assume right now that you would feel pretty confident getting started on this on your own, but we'll do 2 examples before you try a few on your own. In this case, there's 2 different shapes. There is a semicircle, and we're going to find the area of that semicircle. Now, firstly, we need to know that it's 1/2 of a circle. So the area of that shape is 1/2 the whole area of a circle, or 1/2 pi r squared. Because the diameter is given to me as 8, the radius is half of that, so my radius is 4, and I'm going to plug in some of this stuff that I know. I know that my radius is 4 squared, and I can multiply some of this together. Now I'm going to leave the pi in, I'm going to leave it in my exact answer, so I'm going to multiply the 1/2 and the 4 to the power of 2 together, which is going to give me an 8 pi. Now that's the area of this semicircle here. We are not done yet. We need to find the area of this triangle. So I have this triangle, and I need to know what the area of that triangle is. The area is 1/2 base times height. So in this case, my base and my height are perpendicular. I actually don't know what my height is, or if you want to call that the base, but I'm going to say 8 is my base, but I don't know what the height is. And I'm going to use the Pythagorean theorem for this right triangle to find the height. I can't use trig, I can't use special right triangles because I don't know any of the other angles, but I can use the Pythagorean theorem. So one side, or one leg squared plus the other leg squared is equal to the hypotenuse squared. You're going to solve that. X squared is equal to 36, and in this case, x is equal to 6, so that side length is 6 right there. So the area of this triangle is 1/2 8 times 6, and I'm going to just plug that all in my calculator, do that in my head, and that's 24. So I currently have I'm going to use the same colors here. I currently have the area of that semicircle, or that half circle. I have the area of that triangle, and in order to find the whole area, I'm going to add it together. So 8 pi plus 24. Now, if I asked you for the exact answer, that would actually be your answer. But in this case, I want to ask you for your rounded answer. And your rounded answer in this case is 27. And in this case, I wanted to plug in pi into my calculator. I didn't round that and then add it to the rounded one, because sometimes we'll get weird answers. But in this case, I'm going to leave it as is, and because it's area, we are going to square it. So that's the area of that composite figure, both of those added up together. Now in this case, we are not going to do any additions, we're actually going to do a subtraction. So in this case, I have a square. I know it's a square because those 2 sides are the same, and if it's a quadrilateral, I should have put those in there. Then I know that the opposite sides are going to be the same. So I have a square, and I'm going to find the area of the square is base times height, which is 49. And sometimes when I'm doing these subtraction problems, I do like to draw out like a little diagram, if you will. So I have this square, which is 49, and I'm going to subtract this half circle here. Now, we need to find the area of that half circle, because we're going to subtract it from the square, because if I'm looking for my final area, it's that square subtracting that semicircle. So this is a 1/2 pi r squared. That's probably a mistake that students make the most, is they're not taking 1/2 if they have a semicircle. They find the area, they plug it in, they think they're done, but you need to take 1/2 of it. Now, if the whole diameter is 7, my radius is 3.5, or 1/2 of that. So I'm going to plug that in like this. I'm going to multiply in any order. I'm going to multiply the 1/2 and the 3.5 squared together, and that's going to give me 6.125 pi. And I'm not rounding this just yet because I'd rather round it at the very end. I can use my exact answer there. So we're almost done. You're going to take the square, subtract something from it, plug that all in your calculator, and this is where we're going to round by using that pi button. But you'll get 42.875 meters. Oh, again, I forgot these units. Meters squared.